All right, so we're back and we're going to be talking about some Android pen testing stuff, specifically dynamic instrumentation. So let's get into it. So before I kind of talk about this, I want to briefly cover where I've been, why I want to cover this, and just a little bit of background. So first is, the whole reason I made the last series was because I was studying for the Burp Suite Certified Practitioner and trying to get a lot better at pen testing for web applications. Now I'm kind of at a point where my interest has kind of shifted more towards mobile applications, and Android seems to have the most easy to access learning resources through that. However, they are pretty limited. One thing I can strongly recommend, and similar to how the last course was a lot based on the Web Security Academy, this is going to be mostly centered around Hextree.io. They have really good quality courses, up to date, and just really well made videos and lab exercises for you to do, which is probably the most important. And I'll be covering a big part of their dynamic instrumentation one in the demo of this video. Again, the reason I cover these is to just kind of help me remember the stuff better as I continue, and to try and, force me to be accountable with my studying and also be accurate in the things I say in these videos. So those things covered. I want to learn a little bit more about Android application development, and Hextree is kind of the best way to do it from what I can tell. And, as far as certifications go, it seems like, the SANS certification, the one from TCM Security, and another one from eLearn Security, from people I've spoken to who've taken all of them, it seems like they don't really delve into the level of detail that would really be required for you to be considered what I would say based on information I have, an intermediate level Android pen tester. And I don't want to make videos about super entry level stuff, albeit this is that. But I, kind of want to provide videos that can kind of help get you to the next level in a way, instead of just being here's this simple thing, here's how you do it. I want to give good examples and show you guys how it works and give you a better understanding. So, and mostly because it helps me out. So that being said, let's just go ahead and continue. So first, what is dynamic instrumentation? First, I want to kind of talk about, what's a better way to put this? I want to talk about what instrumentation is, because that was something that hung me up when I first was trying to figure out how to define this. So when we talk about instrumentation, that kind of refers to the process of adding code to a running application to monitor its behavior. Something you'll see other people talk about, it's really that instrumentation and dynamic instrumentation is a really broad category of what you can do to an application while it's running. And there's multiple reasons you might want to do this, but, imagine hooking a function, or, in order to do these, the instrumentation things, you need to basically, instead of modify the app source code directly, you inject some piece of code that hooks into the target app's memory while it's running, and then you perform some kind of real-time analysis of the behavior, and that's the whole point. So the typical approach you might do that's more intuitive to understanding an Android application would just be to decompile and examine the source code. And after all, Android applications are just APKs, they're just archives, right? You can just unzip them and then look at the code. Or you could look at them in JADX, which is the decompiler to use from what I can tell. The issue is that some of those applications can be, frankly, too large to be easily understood, or be full of useless logic. Or they could be obfuscated, or, packed or something like that. So in instances where maybe you just want to understand a certain part of the application, or, there's, it's too difficult to understand by just reading the source code, dynamic instrumentation is a good way to kind of bridge that gap, because it lets you analyze the behavior of the application at runtime by injecting, through the process of injecting and executing instrumentation code. So there's two types of instrumentation. This picture on the left is of embedding an application, which is when you patch the application, the APK, with your own instrumentation agent, We'll be using objection to do this. And you can also use like a shared library or something similar. And then injection is when we spawn the instrumentation agent as another process on the system that will then inject itself into the target program's environment. Now, the main reason you would rather want to do embedded over an injected approach is because embedding can still be done in a jailed or like a non-root environment, whereas injection, in order to install the agent and run it, you need to have higher privileges on that system, the system being whatever Android device you're using. Some of these principles I believe are the same for iOS, but for the purposes of these videos so far, we're only talking about Android. There's a blog post down here at the bottom that explains, and that's where this image is from, that explains this process a little bit more in detail. I'd recommend you read it. It's good, but it's kind of difficult to read in my opinion. So what we're going to be doing most of is using Frida, which is a dynamic instrumentation toolkit. You can use it to look at processes, hook methods, run scripts, and tons of other stuff I'm actually completely unaware of. It's a CLI application exclusively to my knowledge, and we're going to be using objection to like embed our what do you call it? We're going to be using objection to patch the APKs so that we can actually get them to interact with Frida. And then also install JADX, because we will be looking at the source code so we can understand some of what's going on, and then use that to kind of develop some Frida scripts along the way. And we're going to be, in our demo, basically, we're first going to be looking at the Frida target.apk. You can download this by registering on hextree.io. Right now, their Android course is completely free. So you could register on there, download this APK and follow along if you want, or you could just watch, do whatever suits you. And then just kind of watch the show. And our demo, which is going to be the rest of the video, not a lot of slides. I'm going to try and edit in all the kind of vocab stuff we cover, or like little tidbits, but basically we're going to be going through the Hextree course in part. I want to say like probably maybe a third of their dynamic instrumentation exercises, just because I grabbed the ones that I thought were really interesting and included them. And then we're also going to be going through a single challenge from Hack the Box that isn't as difficult or as advanced as the stuff from Hextree, but it's just another, perspective of how you might do the same thing, but in execution, it's very similar. So we'll jump into that, and then that's where we'll kind of wrap this up. All right, let's just go ahead and get started. I'll apologize in advance in case I drone on, because there's a pretty good amount of stuff that I want to cover here, and it's going to take a pretty good amount of time. So I've just got a section of my monitor recorded here because I have an ultra wide monitor. So this is the only way to get it to work with YouTube's aspect ratio without completely ruining it. So all the things that we need for the most part are up here in the top left. So first things first, using the Android Studio, you can make a device. In this case, this is a Pixel 8 without the Google Play APIs enabled. I believe this is running Android 14. I'm actually not 100% sure. But again, it's an Android emulator. We don't have, all we have installed on here is a test application that we built. And like I mentioned earlier, we're going to be doing we're going to be going through the Frida target APK from the hextree.io course. So you can see that wait, let me go into my demo folder. So you can see that we've already got this Frida target installed. So before we can actually install this on the system, you can do this by like dragging and dropping an Android Studio and installing it. But before we actually install it, we want to first patch it with objection. So it's not going to work. Maybe that'll work. Yeah, so objection is what we're going to be using to patch in. There's obviously a lot more that this application or this tool can do that I'm just not aware of. So play around with it if you want. What we're going to be doing is using it to patch the APK with the Frida gadget so that it's embedded. So we don't need to have this device rooted. We could root it. I think all you have to do is just use ADB root and you can get in there because we're on there. But we're just going to use patch APK to do it to show. So we're going to do objection APK. I think we have to use -s to specify. Actually, don't know. We do. And then I think we need to use -s for the source APK. So and it should take just a little bit longer. It's not a really long process. And then once this is done, there we go. So you can see it's made this other one, free to target.objection.apk. So now we can just use ADB, and you can see we've got my emulator here connected. I'm pretty sure it's by default in like the USB bridge is how it gets picked up. So what we're just going to do is do ADB install free to target.objection.apk. And now that it's done installing, you can see right here where it is. So we can launch it and start poking around, but I don't think it'll actually do anything until we are hooked up with the Android debugger. So let me close those. And then we'll move on to just using Frida. So if I do, I think Frida-U, Frida target. I think that should be enough because that's just the name of the application. It should just be called Frida target. So if we open this and then hook up Frida to the Frida target application, there we go. So I think that's just the start condition they have built into this as part of the course. But you can see that because we patched it using objection, we're able to actually connect to it. Otherwise, you could also install the Frida agent on the device and then use that to debug whatever application you want. But I felt like covering and doing it all by embedding it would be the better way to do it. So this app has a couple different features. I think we're going to go through, I'm pretty sure the function calling one, enumerate methods. We'll go through some of the tracing and function order ones. And then we'll also go through, we can do the license check ones as well and the dice game. So I think those are all the ones we're going to run through. SSL pinning, I'm not going to cover here because part of it is really buggy with this application in particular. Just doing it this way, I was able to get SSL pinning to work, but I don't have it on the schedule for today. So the first thing we're going to try and do is if we look at the code in JADX, which I can pull up here. Okay, that should be just visible enough. So we look at the Android manifest and we go to the main activity, but in terms of what's going on here, not really anything super sensitive to look into. The next video I post, I don't know if it'll be a video, will be about reversing, but I'm not really sure if that'll be a video or just a blog post. So if that video doesn't come out, assume that it's not coming out. There's a couple of functions here that we can try and call. One is return decrypted string, and it has like this flag here, which I'll need to remember to go back and censor as we actually get these. Or, oh yeah, I can't edit this because I didn't compile it yet. How foolish of me. I'll just have to censor it in post. So, what we can do with Frida is we can run a script with this. So first I'm just going to exit, and we are going to write a script that will first just call this method. So we know it's the, what is it, io.hextree.FridaTarget, and it's an example class. So let me just show you what that will look like. So I already have this demo.js file that we're going to use for this whole thing. So we'll use jama.perform, and then I think it's just like this syntax. I have notes that I'm reading off of that's making this a little easier for me. So we can do let example class be java.use, and then we need to specify that path that we lined out. So it's going to be io.hextree.FridaTarget.example class, because that's what the example class that we want to call. And then pretty sure what we need to do next is we can end that. and then do let example example instance be a new instance of the example class. I think that's the right syntax. And then we can do console.log example instance.return. How was it spelled? Return decrypted string. Okay. Whoops. Why is that not pasting? Whatever. And I think that should be enough. So we can save that and then go back to our terminal and our emulator, and we'll do the same thing. So we'll start free to target, start our free to instance over here. Or wait, I've already messed up. What we want to do is load our script. So we can use -L to load our script of choice. And in this case, it's going to be that demo.js right there. So we're going to do, I wonder if I can do it after this, -L demo.js. We'll see if it loads. It looks like it did. And you can see that that was the decrypted message that was present in this thing. So it looks like flag cryptor is the class that's actually doing that logic. And you could reverse this whole thing and just figure out how to execute the same code on your own machine. But in a lot of cases, it's just easier to trace the calls. In preparing for this video, there was one CTF where I followed along, and I think it was like a medium difficulty or something like that. And the solution that they had provided was like, oh, you're supposed to just reverse it. Or like this convoluted way of reverse engineering the code and figuring out how something was encrypted so you could decrypt it. And then if you just trace the function calls, which we'll talk about in a little bit, you could actually just see it passing through, and it's not a big deal. So that's a cool example. Let's proceed to this next one. It's pretty similar. We just need to provide this string input. So it's just a different name. So we can just go back here and edit this directly. So first, and we'll just leave that open. I think by default, Frida will try and mess with it. So it's still part of the example class. We can still use this. Instead of, I think we can still, yeah, we'll just leave this here, or we'll leave it here in case there's any other ones that are similar. We'll do console log example instance dot, and then just the name of that other class, which is return decrypted string if password correct. Will it let me just copy this? I don't think so. Return decrypted string if password correct. Whoops, why am I on this line? Here we go. And then the password we actually need to pass through it is very secret. So it's a string, right? Yes, okay. And then I think that should be enough. So if I'll open this, as soon as I save it, we should see, oh, what's happening? Frida, not a function. Is my syntax wrong? Frida example class new, return decrypted string if password correct. Am I missing a, oh, yep, there's a spelling error. And then you can see there's the decrypted, text that was in here. So pretty straightforward how you can, just use some general scripts to call some stuff that otherwise wouldn't be accessible from the front, or like from the actual application itself in here. So there's our first example. Let's call something from this flag class. Let me pull up JADX again. Let me see here. Here it is. Okay. So we'll call flag class. So I need to remember here to censor these so that you guys actually go and do it yourself, because you will get nothing out of the course if you just take the flags from this video. So I will do my best to censor them, but you know, it's educational, so I'm trying to show you how it works. So let's see. It's IO hex tree, free to target, flag class, and it's flag from static method. It doesn't require anything. So we can just actually call all three of these. These two are the same, at least in how we're going to be calling them. You just call the static method. It's not a big deal. So you would call those just by, let me grab my, dang, I keep losing track of where my tabs are. Here we go. So get rid of that. Or actually, we'll leave it there because we can use that. Instead of example class, this is the flag class. But we'll leave the name as example class and example instance just to make this more straightforward. Oh, my free agent isn't connected anymore. Let me leave that connected. In here you can see, let's look. Let's just do one of the simple ones. So we'll do flag from instance method. Yeah, let's do flag from instance method. So we can go in here and do example instance return. So it should just be flag from instance method. We'll uncomment it, save it, and then you can see that the flag gets printed out. Pretty straightforward. The next one we'll do is, again, it's pretty copy paste. We can just pass this string in there, flag if you can call me with sesame. So we can just pass in that same thing. It's basically identical to what we just did. So again, flag if you call me with sesame, and then we just replace the password with sesame, uncomment this, looks good, and then you can see the password gets printed out. Pretty straightforward, not that complicated. All we're doing is reading the source code, which you can get by just unpacking the APK, and examining which of these things we can call. Now, another thing we can do is we can trace activities. So let me get rid of all this. And first, like talking about what an activity actually is. If I pull up our machine again, or not our machine, our thing. Function calling, we already did this. Tracing. So when I click any of these, you might be wondering, like, hey, nothing looks like it's happening from this end, so what gives? Well, what we want to worry about is what's actually happening while we're calling these things. So we can just set up a script that will trace activities. So instead of calling it like we did last time, let's just call this example class. And instead of calling it directly, we're going to want to call the Android app activity itself. So whenever an activity passes, I'm pretty sure that should be fine. Before I do that, let me save this, and just so I don't have to censor that for very long. So we'll use that, and then we'll set example class on resume, I think it is. So on resume is anytime you leave the app and come back to it. Similar to this, I believe. So I'm gonna set, I think, or wait, that's not what we want to do. This is going to be, so every time it gets resumed, we want to log that that an activity was resumed, and then we'll call this.get. So this should give us the class name and then the name of the activity. I think that should be all that we need there. And then let's see. So now if I mess around in the app, we should be able to see something, and that it is hooking, and this is saved. Maybe is my logic, or do I need to have? I think I need to call on resume. Let me try launching the app again. There we go. So you can see the activity was resumed. Okay, so yeah, as I remembered, okay, every time we launch the app or resume the activity, it's going to show us this. So we can see this is the main activity, which makes sense. The main activity is just whenever we boot into the app or like whenever we launch it. So that kind of makes pretty good amount of sense. But it doesn't work for any of these smaller activities. So like function calls, or I think tracing, like I don't think it works for either of these. That's because these are implemented using fragments. Let me see if I can grab the, where is it? The logic for this. Let me see if I can shrink this down and make it fit. Okay, I'm not gonna be able to fit this in the window, but it's like these smaller buttons are implemented in things called fragments instead of activities. So because none of these things are their own activity, we'll have to log them as fragments or implement logic that will actually log those things. So we'll leave the activity class up here. Let's say let fragment class be use, and similarly, this is going to be one of those Android things. So I think this can be Android fragment. I think that should be enough, and then we can do fragment class. Same thing on resume. Again, pretty similar. And we can just copy this here. And then I think get class, get name. We'll just do fragment. That should be okay, right? Oh, am I doing something wrong? Didn't find. Oh, wait a minute. I think I know why that's happening. I think that's okay. Fragments are a part of Android X, not Android, for the namespace. Let me do. So now if I trigger something, let me make sure the terminal's open so you can actually see it. There we go. So we're not tracing those, but we're tracing these fragments, which are these individual button presses. So trace, button call, intercept fragment, dice game fragment, SSL pinning fragment, getting started, home fragment. You get the idea. Now we can actually trace those button presses, which is super convenient, especially if you don't want to dig through all the code and find any of these like UI related functions, because if you wanted someone to not find it, you could just fill it with junk, hypothetically, right? If we want to trace, I think the actual like function calls within the application, so these things, we can just use, instead of writing our own JS for this, we can just use frida-trace to help. So again, you can set a variety of different things here. Like you can specify the PID, which we won't be doing, but we're just going to use, you know, the normal way of describing it. So let's see. Something I probably should explain is you have to track the like which functions and classes you want to catch. So I don't want my terminal to crash, so I'm not going to show it out because it's going to be impossible to scroll all the way back up. So what I will do is just kind of explain. I have this in my notes over here off to the side. So let me show it. So normally you need to tell Frida which classes we are interested in. So this is how you might show it. So you have the name of the class here on the left of this exclamation point, and then on the right is going to be the name of the like function you're actually interested in. So thankfully, you can use wildcards for this. So if you don't know, if you just want to get every class and every function getting traced, you can just do something like this, and that will show you everything you need. So let's just package that up. I believe it's, let me double check. Is it, or let me do free to trace help. Yeah, and we want to have it grab the Java method. I'm not sure if that's right. Yeah, because that's just the whole help menu. Either way, we'll do free to trace, for USB, free to target, and then we'll specify that we want to look at io.hextree, and we want to look for all classes and all functions. I think that's good. There we go. So it's tracing 140 functions. We can look at the web UI if we want, but we'll just leave it here. And you can see here, this is already getting put out. This is encoded. That doesn't count as a flag. This does, though. That's a problem. So I'll have to censor these again. But you get the idea. We can now trace function calls however we want. I think even that one, word is very important. So now, like, anything we click in here is going to get logged. Oh, did I just crash? What the hell just happened? Connection terminated. Okay. You get the idea. That's how you can trace certain things. If you just want to trace a specific function, you could do that. So let's say I just wanted to trace, which one was the one that didn't have a flag in it? I'm not going to be able to, I'm going to censor like my whole terminal for a second. That's going to be trace button fragment. There we go. So that should only be getting that one, right? Oh no, I must have messed it up. Oh well. Anyway, you get the idea. You can trace all of the calls and functions that are passing through. Let's say, what's another example? Let's do the thing next on here is intercepting. So, we can intercept any of these function calls. So I think this says intercepting and replacing function arguments. So, if you're not fine with whatever arguments are being given back normally, we can intercept them. So first, I think what we should do is just trace everything, and then we'll click on this example function, and we can see that the class an interception fragment dot function to intercept is fed an example argument interception fragment 2. So what I think we can do is just figure out where this is maybe and go from there. So is that in, where would that be? Interception fragments on click. That it's called here. It's not in the license manager either. Ooh, that's way too many. Here we go. So we can see the content of this. So it's still free to target UI interception fragment. I think that's all we need to know. So what we can do is just get rid of this. Same thing, Java perform. We'll make, whoops, Jesus, var. We want to use that io.hextree.free-to-target.ui .interception fragment space. Whoops, I don't think I had to add that. That should be good. Then we want to set interception fragment function. Whoops, that's not what I wanted. Let's just do intercept function implementation equals function. We'll do this dot. This intercept function takes in an argument, and it'll return. I think that should work. So I think now all we need to do is run that demo. Implementation of undefined. Did I spell that wrong? Intercept function. Intercept function. Is that not okay? Let's just check anyway. Ah, maybe something's wrong. I think, oh no, I can't just name that whatever I want. Let me do maybe that's what we need. Interception fragment, function intercept, implementation is equal to function argument. And that's in here. Okay, let's see if that actually intercepts what we want. Okay, no errors, looking better. I thought we should surely be seeing... Oh wait, yeah, here it is. We can see the values being returned right here. I just missed it because I wasn't paying attention. But example function takes, like we saw in JADX, or like we should see in here. We saw when we were pulling it out. Where is that normal one? Function to intercept. Oh yeah, here's the one. That's why we couldn't just name it whatever. So it takes in an example argument and feeds it back out. And if we look back at when we stack traced, yeah, it's the function to intercept that we want to get, example argument. And then all it does is capitalize what we're inputting it, but we're not inputting anything here. We're just saying to return this. So, you know, you might get it to just return something that's not sanitized in this case, because you're in control of what's returning to the application. Instead of doing this, I think that we could use the argument itself instead of just setting the return value. So what we could use is console.log. I think this is more in line with what we did before. So we'll log the new argument that we want to use. We'll say the argument. We'll call that demo. Return this function to intercept for the argument. And we'll see if that works. Okay, good. It's still running. And you can see that demo gets returned. So we did that in two different ways. Up here, we just specified that this was the return value. And in this case, we input our own argument. So again, multiple ways of interacting with these intercepted functions. Another thing that I think we should do is really the fun one, which is the dice game. So I think I have examples. We could go through all the license ones, but those are kind of boring. And they show flags. That's more editing I'm going to have to do. So let's talk about the dice game. So the way that this works is every single dice here has to have a value of 6 in order for you to win. If we look at it in JADX, we can see that there's the pictures, and I think, where's the win condition? Here we go. So the win condition is that if, what is this? Between 0 and 5, so the 6 on the die in here is the number 5, just so you don't think I'm crazy. Choosing find view by ID, it randomizes the dice, and if all the dice are not equal to 5, then we didn't win. So in order to win this, we need to actually perform whatever, and it'll decode the flag. So I'll have to censor that too. Anyway, let's go ahead and first trace the call so we know where it is, and we have another method of looking at it. So let me just exit. Again, we'll just trace everything, and then we're just going to open up the emulator and roll the dice. So you can see dice fragment, on click, and it's this class name, Google, Android, material button is what we called, that's what we clicked on, and then it's dice fragment dot roll dice. And then it's calling these own individual things. And you can see that those correlate. So 1, 1, 3, 3, 3. Geez, that's actually, I would like to think that that's lucky, but again, we can modify our script so that it actually does some good work for us. So let me get rid of all of this, and what we'll actually do, let's just edit it slower. So we're going to say dice fragment, and it should be free to target. It's in the UI folder, right? Yeah. It's in the UI folder, and it should just be called dice game fragment. Okay, that should be enough for that line. Now we can just make an instance of dice fragment. Random dice. Right, that's the name of this function. Let's look back here. Random dice, yep. And then we'll specify the implementation. Pretty sure this is the same. Whoops. And then we just need to say this dot. So it'll call the random dice function. And same thing as last time, right? Like we could, well, you could, I suppose, just always input. Well, no, this doesn't take any arguments. So I think the best way you could do this is you could either set it to return 5 times. You could just make a loop that does that. Or you could just make it so that whenever random dice is called, we return 5, which I think is going to be easier. So every single time it calls random dice, it's going to return 5. So we save it. It should still be running. And I click roll the dice. And I forgot something. Oh, yeah, we're still just tracing it. We need to actually attach our script. And there it is. I'll censor this just so it's not on the screen. But again, another good example of forcing application functionality. We are almost done. Now we're going to do one more thing, and we're going to do the Hack the Box Supermarket APK. So I've already downloaded it here, and from start to finish, we're just going to follow the same thing. So we're going to do objection, patch APK. We're going to specify supermarket. Again, naturally, right, it will take a second to patch this through. But once it's there, we can do adb install supermarket.objection.apk. It'll take a second. Looks like we're good. I don't know if this will launch without us hooking to it. We can use Frida-PS to debug or look at what processors are there. I think we can do U is USB, and then I forget what IA does. I think that'll just clear some of the ones. But you can see here which things are running, and you can see supermarket as the PID 7209, the name of the application, which is what we used to call it in a second, and then example supermarket. So let's say like before, or maybe there's a bad example. Yeah, I'm gonna have to scroll up way too much. Let's just do it this way. Let's say that we want to, here we go, call this. So we could just do com.example dot, let's say we want to just trace everything that's happening here. Free to trace you instead of free to target. It should be, again, because that's the name of it. And now that we're tracing everything, the app actually opens. Oh, I totally forgot to read the prompt of it. We're tasked with finding a discount code for it. Let me really quick close this. And I'm just going to reopen JADX And I'm gonna pull this up in case we actually need it. So we do open file, supermarket. Okay, so we'll look at the resources, the Android manifest, there's the theme, initialization provider, emoji process. Where's the main? Here we go. There's the main activity. Let's see. Please select item to buy, order placed. Where do they talk about the Well, I guess we're tracing it. Let's just play with the application and then maybe we'll get an idea of what we should search for. Whoops, that broke something. Oh, look at that. I'm pretty sure that's all we need, actually. So as soon as we entered something, for whatever reason it broke. Can I get it to do that again? Well, when I did this before, it didn't break right when I pressed all those buttons while tracing. But either way, this appears to do exactly that. And what is it? It's getting string from J and I from the main activity. So let's look. I think it's all the way... Yeah, so you can see there's these 3 strings here. There's no point in calling them directly from what I can tell. What we can do, I think in JADX, it's Control-Shift-F for find. So then the find menu pops up here. And I'm just going to search string from J and I. Whoops, spelling error. We can see another instance of it. Okay, so back up here, on text changed, it will... What's this doing? Okay, even without... I don't understand this totally, but I don't really think you need to, because from the context clues, it mentions AES a couple times, and then we have these 2 things. This is totally... Like, that's base64 encoded. Let me pull up a... Do an incognito window here. No, it's a bad choice. Let me just do... Let me pull up Firefox, and once it opens, and let me try and shrink this down to the size that we need it to be. We'll go to CyberChef. We'll duplicate this because I'm pretty sure we'll need one more. We know that the input is base64 encoded, but I don't think that really matters. It's from base64, it's just this jarbled mess. So we'll kind of leave that on the back burner for a little bit. We know AES is part of it, and let's just see what's happening. So let's see here. So init2 secret key spec, new main activity, get bytes. So it's turning JNI2 into bytes. And what's happening to JNI3? Well, that's just, it just says AES, it's JNI3, so that's not that important. Base64 decodes the first one. Okay, so I think with that by itself, we can figure out what's actually going on here. So instead of that, let's turn this second part into, let's do, I think what? To hex, we want to turn it into bytes. And then over here, let's do AES. We'll do decrypt. I'm assuming this is the key. And this is our input, right? Whoops. Fine. That's not... Maybe we... Oh, wait. We know that that has to be base64 decoded. So, back to Firefox. I'll make this larger so it's maybe a bit easier to see on camera. Let's throw in from base64. Maybe we need to do a different mode. PCB, that's the key. Input is hex. Is that not okay? I feel like that should be all we need to do. Raw. Hex, ECB. I wonder why that might not be right. Maybe instead of hex, or wait, no, it needs to be bytes, not hex. Can we do? Maybe if we do, be 2 hex dump. Well, that doesn't look right either. 2 hex. Wait, what did I do before? Is that not what I had it? Yeah, because that's not hex. That's interesting. I don't know the IV though. AES decrypt from base 64. I wonder what I'm missing here. From hex, I'm aware of that. Interesting. Why is this being difficult? No padding. That should be okay, right? I feel like that's fine. And I don't think we know the IV, do we? Yeah. Enable to decrypt input with these parameters. Oh, there it is. Okay. So it needed the input it's set to raw, which makes sense because that raw input, like we saw, was like just random bytes. But there's our flag. Again, I'll censor this, so you have to do it yourself. But this hack the box example, this is a medium difficulty challenge, right? And from what we did with like the dice game, that requires significantly more effort. So there's plenty of good examples of stuff here that really, like, from what I can tell in like CTFs, at least from what I've looked at, a lot of them don't really get the difficulty or the like range of expertise that's needed to do this stuff, or maybe the knowledge just isn't out there. So again, thanks for sticking around for that 45 plus minutes of demo that I'm not going to trim down at all because I'm lazy. But, you know, feel free to, you know, leave whatever comments, however you want me to improve the video. But I got to get to editing this, so have a good one.